If you are into AI, you must know what RAG is. I'm not just going to give you the simplest explanation of RAG, I'll also show you RAG in action. No matter where you are in your AI journey, just stick around. You are in for a treat. Let's start with simple explanation of RAG. Imagine you are planning a trip to Japan. A few months ago, you wrote down notes about where to eat and what to see in Tokyo, Kyoto, and Osaka, all neatly saved in Notion or Google Docs. Now, you open ChatGPT and ask, what restaurant did I plan to try in Tokyo? GPT gives you a random answer. Maybe sushi jamai, which sounds right, but it is totally guessing. That is because GPT doesn't have access to your notes. Now imagine you didn't just ask a question. You also gave ChatGPT your trip notes and told it to refer to them while generating the response. This time, ChatGPT searches through your notes, finds the most relevant information, adds that context to your question, and then generate an accurate response with the exact details of the restaurant you actually planned to visit in Tokyo. This is the very basic idea behind RAG, Retrieval Augmented Generation. The process where it searches through your notes to find the most relevant pieces of text, that is retrieval. Next comes augmentation, the part where it takes your original question, that is what restaurant did I plan to try in Tokyo, and augments it by attaching the retrieved note as extra context. Now that GPT has the right context, it creates the final response with no hallucination and no more guessing. Just an accurate, grounded answer because it is based on your own data. This part is called generation. Now we'll see RAG in action, a very simple example of how retrieval, augmentation, and generation work together in a code. But before that, first let's switch over to Google Colab. You can go to colab.research.google.com. If you have not used it before, Colab is basically an online coding notebook from Google, where you can write and run Python code directly in your browser. It doesn't need any installations and doesn't need any setup. It is all cloud-based and free to use. We'll use it to run a quick hands-on demo and see the concept we just talked about in action. First, we need to install a couple of libraries. Feis for search, sentence transformers for embeddings, and OpenAI for the language model. So we'll be using this command to install the above three libraries. Feis is Facebook AI Similarity Search. This is a high-performance library from Meta for vector search. It helps you quickly find the most similar embeddings, which are called vectors, among millions. Next is Sentence Transformers, which is a Python library built on top of Hugging Face transformers, which is designed specifically to create vector embeddings for sentences, paragraphs, or documents. It outputs a single dense vector representing the semantic meaning of an entire sentence or chunk of it. These are the popular sentence transformers which are used. And the third one is OpenAI, which is the language model we'll be using. So we will run this command once to install the necessary libraries. Now, before going ahead, let's look at what we are going to do in our code. I'll show you two sides. One is with RAG and another is without RAG. In left side, I'll show you what is the output when we don't use any RAG. In the right side, I'll show you what is the output when we use a RAG. So, user asks a question, which restaurant did I plan to try in Tokyo? Which goes to LLM, in our case GPT. GPT doesn't actually know your personal data. It only sees the question. Without extra context, it tries to predict an answer based on patterns it has seen before. In the right side, I'll show you what is the output when we use a RAG. So the question goes to the sentence transformer first, which converts every note or document into a vector, basically a list of numbers that represent its meaning. The output from sentence transformer then goes to FICE index. It stores all these embeddings in a searchable database. When you ask a question, it finds which notes have the most similar meaning and then outputs the correct note. This note goes to LLM. In our case, it is GPT. LLM combines your question with retrieved note and then outputs the correct answer. RAG first retrieves your actual notes before GPT answers. The final response is now grounded in your real data, not a guess. Next, we import our libraries and set up the OpenAI client with our API key. This connects our notebook to GPT so it can generate answer. For API key, visit platforms.openai.com. Search for API keys. Here, either you can use your already existing key or create a new one. I usually have different API keys for different platforms, so let's create a new one for Colab. Copy the key and declare it here in your code. Be very careful that you don't share your API key or it can be misused. Now, this is our private knowledge base. We declare it as documents. So this is just for an example. You can actually connect RAG with your database or Notion or Google Docs or any other external data source. Next, we will build the vector index where we turn each note into embeddings, which are basically numerical fingerprints of the text. Then we store these embeddings inside FICE. In very simple words, FICE is like a super fast filing cabinet for search. Once that is done, we will write a retriever function. This little function takes a question, finds the most relevant notes from our database, and returns them. Think of it like asking your digital assistant to check your notes and pull out the most relevant notes. Now here comes the fun part. First, without RAG, we send the question directly to GPT. In this case, GPT might make up an answer because it doesn't have access to your notes. Then with RAG, we first retrieve the relevant note where it finds our Tokyo note about sushi dai. Then we give that note to GPT. In this case, GPT won't make any guesses. It will give an answer which is grounded in your actual data. So here we are done with our codes. Now we will run it. Okay, we got an error here. We are getting this error because we are using the new OpenAI Python SDK, where they changed how to set the API key. Instead of OpenAI.api.key, we need to create a client. And then replace OpenAI everywhere with the client. So we are done here. Now, hopefully, it should run without errors. Let's see. Yes, we got the output here. Without RAG, we got an incorrect response based on the model training. With RAG, response is grounded in our notes. We got the correct response. So this way, we can give updated context to LLM models using RAG. You can refer to the complete code here or head over to my Colab link to try it out yourself. If you find the video useful, please like my video and subscribe to my channel. See you in the next one.